You wouldn't use a sledgehammer to crack a nut. That's over-engineering, building more complexity than you need, which is commonplace in software. And that's not because software developers are stupid, quite the opposite. In the past, it was seen as best practice. Future-proof your code, anticipate the likely upcoming requirements. And that takes careful thought and good design skills. However, in test-driven development, we do things differently. TDD still needs good design skills, but it changes the constraints on the design and makes testability a priority. It has a surprising amount of consequences. So in this team learning session, we'll talk about getting your priorities right in software design. Hi, I'm Emily Bache. Welcome to my channel. I would like to thank my sponsor, Tuple. They make a tool for remote ensemble and pair programming. A small, bootstrapped team of engineers who care deeply about software quality. I've tried Tuple and it worked well. It was really smooth, especially to switch who is typing. It feels great to partner with like-minded people and have Tuple as our first sponsor. If you're looking for a tool to make pair and ensemble programming easier, more effective and fun, check out the link in the show notes. This video is designed to be done with other people in your development team, and the focus is on coding skills and building up your team. If you haven't seen one of these videos before, I recommend you watch right to the end because the last part is a session briefing that explains more. Let's go to the shared online activity board where I've prepared materials for you. The warm-up today is to start to get you to think about design and the kind of decisions that you make at the lowest level in the code when you're designing classes and methods. So I've got a bunch of ideas here which I've gathered from various sources around the internet. And if you think I'm missing something really important, you can always add a note here. And then I'd like everybody individually to vote for your top 4 by grabbing one of these markers and just copying it 4 times next to the 4 things that you would prioritize in low-level design. Now, of course, I don't know what your group has come up with, but I imagine your frame looks something like this now. You've got various votes for various aspects. So this group I did this with before, there were lots of votes for testable, information hiding, small methods, and modularity. Your choices, of course, may be different. And we have personal preferences here. So I'm interested not only in what you say is important, but what actually happens when you're coding. So we're going to go straight into a coding exercise now. I want you to code up FizzBuzz. And this is probably a familiar problem to many. It's a little thing where you have to print the numbers up to 100, one on each line, but you replace the numbers that are divisible by 3 by fizz, and the numbers divisible by 5 by buzz, and if it's divisible by both, you write FizzBuzz. So please write a program that would do this, and use your normal coding style and your normal design priorities. And if you wouldn't normally use TDD, then don't use TDD. I am putting you under a little bit of time pressure. I want you to complete this FizzBuzz in under 10 minutes. So try and make the most of your time and express your design priorities in the way you write this code. I hope you've had some fun writing some FizzBuzz code there. So you should be looking at various different implementations now that you've written that express your design preferences. Well, I've got 6 more implementations on this frame, and all of them actually do the same thing. They all work. They all produce the 100 numbers for FizzBuzz. Now, the thing is that you can kind of see, though, that the code gets bigger as you go to the right. There are more design elements in the later versions. But what I want you to do now basically is review this code and compare it against what you've come up with. So there's a pointing finger here that you can copy next to the number from 1 to 6 that is closest to the design that you've come up with. And then as you're going through, you can also write sticky notes saying aspects of these 6 designs that you like or don't like, or that are similar to what you've done or not similar. So basically that's the active review. Go through which one is most similar to what you wrote, which one do you prefer, and then when everyone's done that, you can have a little discussion in your group. So is there a difference between the designs that have come about through test-driven development. If anyone in your group has done TDD, did they come up with a different design than the people who didn't? And then are there any of these designs that nobody likes out of these 6, or any that you particularly do like and you would like to have? And just have a bit of discussion, basically. I want you to discuss about the designs and what you prioritize and what you think is good, and whether TDD makes a difference. So of course I don't know what your groups have come up with, but when I did this with another group, I had some of them were using test-driven development, and they came up with solutions that they thought looked a bit like number 3, and some of them weren't using TDD and came up with solutions that looked more like 1 and 2, and they had various comments about this code. So if we just zoom in on number 1, which is what several of the groups came up with something similar to this, and the comment, well, this is simple and straightforward, and it's certainly very short. And if you're just coding this with no thought for testability, this is a good solution. But it is a little bit difficult to test because it's mixed together the logic for calculating the FizzBuzz result with the logic for printing that result. Which is why if you're using test-driven development, you might come up with something more like version 2 or 3, both of which separate out the logic for calculating what is the next number from printing that. So it makes it just that little bit easier to test. So that's why people using test-driven development would tend to have just a little bit more, a little bit more design, a few more design elements perhaps, than the totally naive, untestable approach. Well, it's not totally untestable, but yeah. But I mean, you only had 10 minutes, so that probably explains why very few people are coming up with anything that looks like 4 or 5. Just a small comment on 3. Some people don't like the multiple returns in that, and they fixed that, but otherwise it looks fairly similar to 3. But not many people in 10 minutes would come up with 4 or 5 because this introduces more complexity. There's more design elements here. And I think everyone who reads through number 6 agrees that this is a bit ridiculous. This is over design. There is way more code here than you need to solve FizzBuzz. And actually, this is an example of kind of FizzBuzz Enterprise Edition Lite. So FizzBuzz Enterprise Edition is on GitHub, and it's a parody. It's an amazing piece of code. It's like this huge amount of code to solve FizzBuzz. And it's like 89 classes, 1,000 lines of code, and it does exactly the same as the program that you can write in like 10 lines of code. So of course nobody would write code like this in real life, would they? No, I mean, there's lots of reasons not to write code like this. You don't have to be an adherent of TDD to write code that doesn't look like this. But I think my point is that there's kind of a scale when you're doing low-level design between too little abstractions and too many abstractions. And the job of design is to find a good balance. And test-driven development might help you to do that. The creators of extreme programming, including Ron Jeffries, came up with this design advice. You ain't gonna need it, or you're not gonna need it. Which is basically saying, don't do more than you need to do. Avoid over-design. Don't build too much. Just focus on the tests that you already have and write the simplest code you can come up with that will pass the tests you have. And worry about the tests that are coming up later, when you've got those tests. So you're always striving to build the simplest thing that could possibly work for today. And this mantra, Yagni, you ain't going to need it, will help you to remember that. But of course the question comes up, well, what is simple? What do we mean positively by simple? So then we get to Kent Beck's 4 rules of simple design, where he says, you know your design is simple when firstly the code runs all the tests, and then secondly it communicates all our design ideas so you can read and understand what it does. But thirdly, there shouldn't be any duplication. And fourthly, we want to minimize the size of the code, the number of elements, the number of methods and classes within that. So this is a prioritized list of what we mean by simple code. So if we look back at the design ideas that I came up with in the Connect exercise, we can see that some of these correspond to Beck's rules and Yagni. So this no unnecessary elements or extension points, that's Yagni. You ain't going to need it. Testable and has test, that's Beck's first rule. Design choices are clear and the code is readable, that's the second rule. That's the second most important thing to have, according to Beck. And the third thing was avoid duplication. And fourthly, we want small elements. So I think it's interesting to note that the design ideas that come from extreme programming and test-driven development might not be the same design priorities that you have. Test-driven development will change the way you approach design in software. In this demo, I'm going to show FizzBuzz with TDD. And it might not be exactly the same way that you would approach it, but bear with me. I'm aiming to show how TDD changes the way you do design. I'm working in small increments, building up the tests as I go. And that should be the same whichever programming language you're using. The first step in solving a code kata or a coding problem in general is just to think a little bit about what you're trying to do and try and decompose that into small pieces that you can tackle one at a time. So I'm just writing a little test list here for FizzBuzz. 1 will turn into 1, 2 will stay as 2, 3 though will turn into Fizz, and then 5 of course, oh no, we should have 6 as well probably, just to check we've got all multiples of 3. Then 5 turns into Buzz, and then we can just print all the numbers that it wants up to 100. So the first test then is for 1. So this is ordinary numbers which are preserved. And the actual value then is I'm going to need some kind of FizzBuzz class. This is Java. And I'll add a method to it called convert, which I can pass the number I want converted. So this is some design I just did. I've decided I'm going to have a convert method in my FizzBuzz class. And I can just quickly create a skeleton for that, enough to let me run the test and see it fail. And then, of course, I can make it pass just by returning 1. So that was the simplest thing that could possibly work to get that first test passing. And now I'm just rearranging my windows. And then 1 is not the only ordinary number. We should also have 2. And that should also be converted without change, which will force us then to make our implementation just a little bit more elaborate so that we can handle any normal number. So I'll cross those ones off my list, and then I'll just make a little commit. I can handle ordinary numbers as long as they're not Fizz or Buzz. We're doing well. Are you enjoying the session? Please remember to subscribe to my channel and like the video. What we all want is higher quality code so that we get better software delivered sooner for a lower cost. And it takes skill to design good software and to do test-driven development. And perhaps you'd like some more support with that from people with experience? I founded the Saman Society for technical coaches, and you could get help and advice. Sign up for our newsletter on the website or come along to one of our free events. Saman Coaching, growing excellence in coding together. Okay, so the next thing on my list is Fizz numbers, so let's write a test for that. Fizz numbers are multiples of 3, and the first example that we've got there would be 3, which should turn into Fizz. So we'll start with that one, and again, I've got a failing test. Now I should go to my implementation class, and the simplest thing is just to add an if statement to detect this case and return something different. So that's not very much design went on there. It was just like, what can I do that is simple as possible? And then I need to force myself, though, to generalize this to any multiple of 3. So I'm putting in another example there of 6. And then I'll just check if it's a factor of 3 or 3 factors it. There we go. So now I've done not only ordinary numbers, I'm doing Fizz numbers. Make a commit for that. I like to commit after every small step that I've taken, so it's easy to back up if I go wrong, or and then I get a record of what I was doing. Okay, so the next kind of numbers that I need to cover are Buzz numbers, and they are multiples of 5. So I'm going to want something similar here, except it's going to check for Buzz when I give it 5. And failing test, now I can write some code. And again, the simplest thing is just to add an if statement. This time I'm checking in multiples of 5. And you see, I jumped straight to divides by 5 rather than going to equals 5. Yeah, that seemed the simplest thing from here, from where I was. So Okay, I've now done buzz numbers. Make a little commit. And then I'm looking at my list, and the next thing was print all the numbers. And I'm like, oh, I forgot FizzBuzz numbers. Not done yet. We need to handle numbers like 15 and 30. So let's add that to our test list and then add a test for it. So we need to do FizzBuzz numbers. And it's very similar to the previous test. FizzBuzz, when we convert 15. Now we've got a failing test. What's the simplest way to make this pass? Actually, it's just add another if statement. I mean, I could do something fancier here, but actually, I think this is pretty clear. If it divides by 15, then it's a FizzBuzz number. Yeah, and I'll just add an extra assertion there to make sure that I'm covering all multiples of 15. Cool. I'll commit that. So now I'm kind of thinking that my convert function is probably pretty much ready. And the next thing on my list was printing numbers. So I've just showed you kind of TDD for developing a single function with which does different things in different circumstances depending on its argument. But now we're doing something a bit different. We want to do printing. So actually I'm going to flip to the main entry point for FizzBuzz, which is going to be some kind of main function, because I need to print the first 100 FizzBuzz numbers. So I'm kind of guessing it's going to look something like this if I work from the outside in. I'm going to construct a FizzBuzz and then ask it just to print. Except it might be good to be able to tell it where to print. I want it to print to system out from the main function, but I might want it to print somewhere else on another occasion. So I can just generate the skeleton for that print function, and then I can just write something like a hello world, just so I can test out the main entry point. So when I run that, it compiles, I get hello world. Great. But before I do any more work developing this print function, I should write a unit test for it. So this print function is unit testable because I can pass in the print stream that it should print to. So let's have a test for this. So it's going to look very much like that, except I'm going to want to print to a different print stream. Oh, and it's just pointed out that my print method is not public. Yeah. So sometimes when you're making your code testable, you'll increase the visibility of things for the test, and I think that's a good trade-off. Testability for slightly more public stuff. You may have different opinions, but okay. So I need a print stream from my test, and I need to back that up with some kind of storage that I can interrogate from my test. So let's create about a byte array output stream. This is Java. That's a storage that I can put characters into, and then I can get them out again after I call my function. So the result is then going to be, I ask the storage to convert itself to a string, and I have to give it a character set to use for the conversion. So UTF-8 is pretty standard. Great. So now I've got a result I can make some assertions on. So I'm expecting the first bit of this result to be the string 1 on its own line. So if I just take the first 2 characters of that result, I should get 1. And then I have to remember to actually run the test and not the main function. But there we are. I'm expecting 1, and I'm getting the first bit of hello world. So that's great. Now I can start to test drive this function. So I'm going to print 1 there, and that's enough to make this test pass. And then, of course, I'm in green, so I should either refactor or write a new test. And I'm not done yet, so I need to write another test. And at this point, I'm actually going to just recycle the existing test, and I'm going to make more assertions in it because I'm still testing the same function. And the next assertion I'm putting in is, well, if I split on new line, I should have 100 elements here. Because I should be writing out a line for every FizzBuzz number. And that is going to fail if I ask it for the splits on new line and then ask for the length. So let's put in a for loop here, looping over 100 numbers, and printing out 1 every time. That will make this one pass. Great. So again, it's green, so I need to either refactor or make another test. I think I'm going to write another test to force myself to fix this. So it should end with buzz. The 100th element of this should be buzz, because 100 divides by 5. And that's 5 characters long. So if I take the last 5 characters of my string, I should get buzz, but I'm not. I'm getting 111 and all that kind of thing. So that will force me then to improve my implementation. So I think what I actually want to output here is the conversion of the number I'm on. Let's try that. Didn't work. And I was expecting 1. So the first assertion I've got there is failing. I'm getting fi. Right, I think I spotted what I did wrong. I should be starting from 1, not 0, and going up to 100. And that actually is enough to fix it, the tests. And then if I run the main function now, I can see I get all the FizzBuzz numbers. So that second part of TDD, I was kind of recycling the same test to force myself to improve the implementation. And there I think I'm done. All that's left is to delete my test list and make a commit. Here at the end of the session is your chance to really think about what you've just learnt about test-driven development and about design. So perhaps discuss in pairs or small groups, how does TDD affect your design choices? And is this different from your usual design priorities? And what do you think about that? Have a nice discussion. Great stuff. So when you're programming today, I hope that you're going to make testability a design priority and reflect on how that changes things. Happy coding. This is the session briefing intended for the developer or the coach who's going to host this guided learning hour. And if you haven't done one of these before, I've got another video, Guided Learning Hour How To, with more information. I recently updated it, so even if you watched this video before, it's a good chance to review it again. And don't forget, you can get additional resources via Patreon, including a copy of my activity board. There are 4 points in the video where I ask you to pause and lead an activity with your team. We've got the connect, a connect exercise, a concept discussion, and then a conclusions discussion. Let's go through them. The initial connect is not really a chance for a big discussion. This is just people starting to think about what they already know about design. So just make sure everyone knows how to grab a marker, copy it, and move it next to their personal preferences. And do encourage people to add things if they think there's something missing here. But don't get sidetracked into a big discussion. The next step is a concrete exercise, although I'm putting this in the connect category because I haven't introduced any new concepts yet. I just want people to get a chance to really think again about what they already know about low-level design and what they prioritize through doing this exercise. 10-minute time limit, that's important. You don't want this to take forever. 10 minutes is enough for a lot of programmers to produce FizzBuzz and more. So if people finish really quickly, do remind them that there probably should be some unit tests, and just to make sure that they've taken full advantage of everything they know about making a good design. Get them to make some design improvements if they have time left over. But then the next part is really where the discussion comes in. So this is actually kind of 2 parts to this design review. Everybody has got their own little solution to FizzBuzz, and then there's these 6 other solutions that they've got to review. So it takes some time to read that code, so make sure they've got time and space to read it in pairs, and time to assess which one their solution is most similar to. And this is where it's an advantage if you're a bigger group with more pairs, because there'll be more variety of solutions. And particularly if some people have been using TDD and some haven't, you'll probably see, again, more variety in the solutions. So that's good. And then hopefully people will put the big pointing fingers about the ones that are similar to theirs. And if they can't decide, perhaps you can go and help them to look at, well, does your solution separate calculation from presentation? Then it's not number 1. Does your solution introduce domain concepts like factors? Well, then it's probably nearer 4 or 5, something like that. Help people to work it out. But it's not crucial that they pick it. They won't be exactly the same as what they've got, of course. And then when everyone's had a chance to read the code, then you can bring it back to the whole group and perhaps then just answer those additional questions about what difference does TDD make, and are there any of these designs that you really don't like? That's a leading question, because I'm hoping that there will be some agreement in your group that number 6 perhaps isn't the best way to tackle this particular FizzBuzz. But anyway, then I go on in the video to explain about the theory about Yagni and simple design. And then later in the video, there's a demo of me showing TDD. And I've put this in because for a lot of groups, they won't be very familiar with TDD. And it would be a good idea to just see it again, see somebody doing TDD and what it looks like when you're doing simple design. But of course, if your group is a little more experienced with TDD, they might not find that very interesting to watch, and they'd rather do it themselves. Because there are almost no downsides to doing a code kata again if you know it well. Because you can train fluency with your tools, you can build up your habits, because a simple coding problem that you've solved before means you have brain capacity left over for absorbing more about Yagni and design rules and thinking about not building more than you need. So you could do this part as an exercise instead of watching me do the demo, if you think your group would benefit more from that. So I'll leave that up to you. But in any case, there is the conclusion section where you're going to be just talking in small groups about what do you think about all this. Is the rules of simple design the thing that you could start doing? Or is it totally foreign and not what you would like to do at all? So this is the chance for people to express their own opinions and discuss that with their peers. So let them do that. This session is much more fun if you do it in a group. So I hope you'll try it out and get some good discussions going.